This is section 2.5, part 5, and we are going to identify direct variation. Alright, and we don't have an equation. All we're given is a table with a set of values for x and a set of values for y. So, in order to do this, we need to use ratios to identify direct variation. So, alright, I've got ordered pairs given to me. Alright, so I'll get my highlighter out here. I'll use a different color. Alright, so we've got this set of numbers here that creates one ordered pair. This is my second ordered pair, third and fourth ordered pairs. I'm going to need to check the ratios for each of these ordered pairs using the direct variation equation. Alright, and you have to check every single one. Alright, because 3 of the 4 may be the same, and if you don't check the fourth one, you might see that the constant of variation is different. Alright, so you want to make sure you're checking every single one until you find a difference. So, let's start with the first ordered pair. So I'm going to label this ordered pair A. So I have a reference point here, and I'm going to use my direct variation equation. And I'm simply going to plug in the values from the ordered pair into the equation, solve for A to see what the constant of variation is. So my value of y is 1, so I have 1 equals A times 2. I'm going to divide by 2, and I can see A equals 1/2. Now I need to check B. Hopefully A is 1/2, and if it is, we're on our way to finding direct variation. Alright, but remember we do have to check them all. So I'm going to plug in 2 for y, and then A times 4. Divide by 4. And I can see A equals 2/4, which again simplifies to 1/2. Now I'll check the third ordered pair, which is C. I've got my direct variation equation, y equals ax. 3 goes in for y, a times 6. Divide both sides by 6. A equals 3/6, which is 1/2. And I do need to check the last one, alright, just to make sure it is, in fact, a constant of variation of 1/2. So I see y equals ax, plug in the value of 4, equals a times 8. Divide both sides by 8 so I can solve for a. A equals 4/8, which is 1/2. So I can see all my constants of variations are the same. A equals 1/2 in each case. So if that happens, you do have direct variation. So you would say direct variation exists, or you can simply write yes, or direct variation. So direct variation exists in the first problem. Let's look at the second one, and let's see what it looks like when direct variation does not exist. Alright, so again, I've got my ordered pairs, so I'm going to check each of these individually until I find a difference. And if I don't find a difference, then again I know direct variation exists, but I already gave you a heads up that there will be a difference here. So I'm going to check the first one. So I've got A, and I see y equals ax. Plug the value of y in, which is 1. So 1 equals a times 1. A times 1 is simply 1, so a equals 1. My constant of variation for the first ordered pair is 1. Now I'll check the second ordered pair, where I have y equals ax again. The value of y is 4. A times 2. Divide both sides by 2. My 2's cancel there, so I see a equals 4/2 or 2. And again, you can see these are not the same. Alright, and once you find a difference, alright, you can stop. There's no need to continue checking. Alright, we can see these are not the same. So because of that, alright, there's not direct variation. All the values of A have to be the same in order for there to be direct variation. And that's it.